Now we are going to start with the MCQ of the fourth chapter. So here you can see question number one. The graph shows how the length of the string changes when the stretching force is increased. And you can see this graph. The y-axis is given is the length, and the x-axis is given in the force. In the Hooke's law region, what is the spring constant for the spring? So we want to find out what is the spring constant. So here I have attached the formula of the Hooke's law. We have learned the Hooke's law, what happens when we attach this the mass to the spring at the bottom. What will happen? The spring will extend, and the force that we are attaching at the bottom is directly proportional to the extension. So we have seen this force is directly proportional to extension in case of the Hooke's law. Okay, so here from this formula we know what is the spring constant is nothing but spring constant is coming out to be F divided by x. F divided by x. If I take this x to the left hand side, this will go into the denominator. So F divided by x is nothing but the spring constant. Okay. So this graph, you can see this graph, the y-axis is length, x-axis is nothing but the force, and we know that this when the force is directly proportional to x, they are directly proportional to each other. That means there is a straight line. Either x is proportional to f or f is proportional to x. That is nothing but the same thing, and we get the straight line in that case. So we can see up to this line. I will mark this with another color. Up to this point, okay, from this initial point to this end point, there is a this is the region of Hooke's law, because this is a straight line. That means force and this force and the extension length are directly proportional to each other. Okay, so how we can find out this spring constant? Spring constant is what? It is nothing but force divided by the extension. Okay, so we can find out that with the help of the concept that is nothing but the slope. Slope is what? y2 minus y1 divided by x2 minus x1. That is nothing but change in the y-axis divided by change in the x-axis. So we can find out the slope, and for this particular length we can find out the slope, and I'm selecting here 2 points, initial point with the red color, final point with the red color. So I will mark here the triangle basically. So this can be the triangle, and with the help of this triangle, using this triangle thing, we can find out what is the slope. Okay, so here you can see what is the change in the y-axis. Change in the y-axis, on the y-axis the final point is 20, initial point is nothing but 5, so I can write 20 minus 5, and on the x-axis you can see this is the final point is 5, initial point is nothing but 0, so it is 5 minus 0. So we are getting the value of 15 divided by 5. That is nothing but the slope, which is nothing but 3. So here what is the y-axis? Y-axis is nothing but the length. Okay, I can express that with the letter x, and x-axis is nothing but the force. So the slope is our x divided by force is nothing but 3. And what is the spring constant? It is a f divided by x. So this should be equal to reciprocal of the spring constant. Okay, this should be equal to reciprocal of the spring constant, because spring constant from the formula is x divided by x, f divided by x, and from this slope we are getting x divided by f. So it should be reciprocal. They are reciprocal to each other, so it should be 1 by k. So k value, if I do the reciprocate of 3, reciprocal of 3, I will get 1 by 3. That is coming out to be 0.33. Okay, the 3 is recurring over here, so we can find out recurring t. We can say recurring 3 or 0.33. So this is the value of the k, and you can see in the options, D is the option where we are getting the value of 0.33. The unit is Newton by centimeter, because this is given in centimeter. This is the Newton. K is f divided by x. F is nothing but Newton. X is nothing but centimeter. So unit is Newton by centimeter. So you have to calculate the slope of this line. Okay, then you will get the value of the x by f. We have to do the reciprocal of that. Then you will get the value of k. Suppose if they give this as a force, y-axis as a force, and x-axis they give as a extension, then directly we will get the slope is equal to f divided by x, there is no need to do the reciprocal things. Okay, but they have given x divided by f, so we have to do the reciprocal of the slope to find out the force constant k. Okay, I hope you understood this problem. Now we will see the second problem. Which combination of the forces produces a resultant force acting towards the right? Okay. We want the resultant force acting towards the right. That means the force acting towards the right hand should be more than the force acting in the left hand. Okay. So force acting on the right hand should be more than the force acting in the left hand. So here in the option number 1, you can see this is 10 Newton is acting towards the left side, and here this is 5 plus 2 forces are acting, so 7 Newton is acting in a right hand direction. So you can see the 7 is less than 10, so it should move towards the overall force will be in the left hand direction, or we can say resultant force is in the left hand direction. In this case it is 4 plus 3, that is nothing but the 7 Newton. So this we can say is our option, because resultant force is what? Resultant force will be 7 minus 5, that is 2 Newton should be in the right hand direction, because here right hand force is greater than the left hand force. So option number B is right. Here you can see 6 plus 4, 10 Newton is in the left hand direction, 10 Newton in the right hand direction, so resultant force will be equal to 0, because they are equal and opposite. Here you can see this is 5 plus 3, it is 8 Newton in the left hand direction, and right hand direction it is 7. So you can see here left hand direction force is greater than right hand direction, so it will also move towards the left hand direction. So option number B is only the correct one. Okay, one direction you can consider positive, another direction you can consider negative to find out the resultant force. Okay, here we need to just find out which direction the resultant force will act. Okay. So here option number B is the correct. Now question number 3. The weights of 4 objects 1 to 4 are compared using a balance. Of which object is the lightest? So you can see here the balance, 3 balances are here, and the weights are kept on this pans. And here here is the importance of the moment formula. So I'll write down here what is the moment formula. We know that moment is nothing but equal to force multiplied by the perpendicular distance. Okay, that is the formula of the moment. So in this case you can see these balances are this weights are kept on these spans, and you can see this middle one is nothing but the pivot. This one is the pivot, this one is the pivot, this one is the pivot, and you can see these are the attachments. These are the attachments here, and this distance of these attachments from the pivot is constant. Okay, and that's why we can directly see the level of the objects to identify which object is heavier or lighter. Okay, if suppose these distances are not equal, okay, these distances are not equal, then definitely only the level or position of these objects are not sufficient to identify whether these objects are lighter or heavier, because we are considering here the moment formula. Not only the weight or mass is important, but the moment is important. Moment is nothing but force multiplied by perpendicular distance. Here no distance is perpendicular, because all the this horizontal attachments are inclined, though those are not exactly horizontal. But since the distances from these attachments are equal, we can consider directly the objects, the level of the objects which are kept in the pan. So here in the first balance you can see the weight 1 is below and weight 2 is above. So definitely weight 2 is nothing but smaller than 1. Here also weight 2 is above and weight 3 is below, therefore 2 is definitely smaller than, or you can say lighter than 3. Okay, but here you can see from this we have observed that 2 is lighter than 1, 2 is also lighter than 3. But from this you can see weight 4 is above, weight 2 is below, and 4 is still even lighter than 4. So we can say the lightest weight is nothing but weight 4. So option number D is our answer. Okay, so I hope you understood. Here the moment formula is used Since R here, this R is constant almost.